Terrestrial organisms breathe air, ventilate their lungs with air, whereas aquatic organisms like fishes use water as the respiratory medium. So, how does air compare to water as the respiratory medium? Well, in order to sort of determine this, we got to go back and we've got to review a couple of different concepts from chemistry. The first is the ideal gas law, which says PV, pressure volume, is equal to the number of moles times the universal gas constant times temperature. Okay, so that's the ideal gas law. The second one that we have to go back and look at is Henry's law, which says that the concentration of a gas in a solution is equal to the solubility times the pressure. Now, these two equations, your ideal gas law and your Henry's law, in their current forms, aren't overly helpful for us as physiologists. So let's do some rearrangements. First, let's rearrange this ideal gas law. So what we're going to do is we are going to divide both sides by V. So we will get pressure is equal to nRT over V. Now what I'm going to do is I'm going to divide both sides by RT. So what I'm going to get is N over V is equal to P over RT. So N over V, this is the number of moles per unit of volume. It's essentially our concentration. So we can sort of move that over here. That's N over V. Okay? And we know that this is pressure, right, times pressure. So this must be 1 over RT. And that tells us our solubility. So now we've got some working forms of the equation that we can use and look at different systems. So what I want to do is I am going to draw a box. And in the box, I'm going to put fluid, water. And I'm going to put 1 liter of air. And I'm going to put 1 liter of water. Right? Now, oxygen is not very soluble inside of water because the solubility of water is low, because that oxygen wants to interact with that water in a negative fashion. The water wants to push that water out. Water is not good for dissolving oxygen. Oxygen has a low solubility. So what that means is that if I put some molecules of oxygen here and here, there is going to be a pressure that this oxygen exerts on the walls. Okay? So we know that the pressure of the system, the total pressure, is equal to the partial pressures of all of the different sort of components or constituents. And we know that because that is Dalton's law, right? That the total pressure is the sum of all the partial pressures of its parts. Okay? Now, this oxygen, some of it will move into this water so that the partial pressure, let's say the partial pressure up here is 0.2. We'll say that the partial pressure down here then becomes 0.2 because water will move based off of the partial pressures so that the partial pressures in both systems become the same. But remember, this water, these water molecules inside of here, they're going to push that oxygen sort of to the outside, right? And so even though the pressure is 0.2, the overall concentration of that is not the same. So let's say that the concentration, and I'm just going to make these numbers up, that the concentration of the air is, let's call it 9 molar, whereas the concentration of the water is 0.3 molar. Okay? So let's go look at a system here. Let's say I have a tube. And in this tube, I'm going to put an O2 sensor. It's going to monitor oxygen. All right. And what we are going to say is we are going to push this water through this tube. Okay. And so what we can say then is that there is essentially 0.3 moles per liter in water. And up here we have 9 moles per liter. Okay? What would happen if I want to detect, let's call it 30 moles? Right? I want my O2 sensor to detect 30 moles. How much water do I need to push through here? How many liters? I got to do 30 divided by 0.3, which is equal to 90 liters. Right? So I've got to push 90 liters through that tube. Right? Now, let's have another tube up here. But this time, I'm going to push the air through that tube. And again, I want to detect the 30 moles. Okay? So how many moles do I need to push through here? How many liters do I need to push here? Well, now I need to do 30, divide that by 9, which is 3.33 liters. So in order to get the same overall number of molecules, oxygen molecules, from the air, I only need to move 3.33 liters. Whereas here, I need to move 90 liters of water. So based off of that poor solubility of oxygen in the water, I need to move substantially more respiratory medium across the respiratory surface to have that level of exposure. So water as a respiratory medium is overall not that efficient, right? And it's because of this here, right? Because it takes more movement of the respiratory medium over the surface to get exposure to that content. And so that is why air is a little bit more efficient, and one of the reasons that moving into a terrestrial environment was beneficial.